This lesson, it comes from Unit 1, Lesson 7 for absolute value functions. For absolute value functions, you're given the function equation, but the only difference is we've got absolute value symbols in our equations. So what we want to do is evaluate the function for the given variable. So for this first one, we're looking at it for f of 3. So this means we're going to substitute in 3 into our function for x. So if I were to substitute in 3, we would have the absolute value of 3 plus 2, and then f of x equals the absolute value of 5. And remember, absolute value is always going to return the positive form of that number because it's returning the distance a number is from 0, and distance can't be a negative value. So the answer for this one, for f of 3, equals 5 because the absolute value of 5 is 5. Looking at our other example, it's a little bit more complex. We've got numbers outside of our absolute value symbols, and we've got an equation variable part inside the absolute value. But we're still going to solve the same way by plugging in the known value for x and simplify. So we have f of x equals 4. And when it's on the outside like that, that means times whatever's on the inside. So 4 times, and then we're plugging in 4 for x. So 4 plus 5 over 3. And we want to simplify inside that absolute value chunk first. Just like order of operations with parentheses, we want to simplify inside there first. So we have f of x equals 4 times 4 plus 5 is 9, so 9/3. Simplifying our next step, we have f of x equals 4 times 9/3 simplifies to 3. So 4 times the absolute value of 3. The absolute value of 3 is 3, so we have 4 times 3, giving us an answer when we're evaluating the function for 4, for x equals 4. 4 times 3 equals 12. So solving the functions for the given value is still the same process we've been doing. What comes different, or what's a little bit different, is when we graph them. Previous functions were all as a straight line because they were like linear equations, but this absolute value piece gives it a slightly different graph, and I'll show you that in this example. So if we've got a function, it's an absolute value function because it's got these bars listed, and they're giving us domain values to plug in to our function equation, and this f of x represents our range values. So if we were to plug each of these in, so for example, plugging in 3, 2 times 3 is 6, 6 plus 2 is 8, so we're finding the absolute value of 8, which is 8. Next one, 2 times 2 is 4, 4 plus 2 is 6, the absolute value of 6 is 6, and so on. So we'd keep going. After you plug in all of those values, so we plugged in 1, we got out 4. Plugged in 0, we got out 2. We're still using the same function equation. When you look at the graph, notice how it's not just a straight line anymore. We've got these numbers, it comes to a vertex point, and then it goes back up the other way. Okay, so what happens here, so we're still graphing our domain and range. This is one coordinate, so 3, 8. So 3, 8 is this point here. 2, 6 is the next one in our table here. 1, 4, so over 1, up 4, 0, 2. When we plugged in -1, we got out 0. This was our vertex point. -2, 2, and so on. You'll see that when you're plugging in the values that these are going to match up on each side, and when you compare the two sides of this graph, if we look at the slope, the slopes are going to be opposites of each other. So on this one, if I look at this slope, it's got a rise of 2, 1, 2, a run of 1. So the slope on this side, the slope on that side equals 2 because we had a rise of 2 and a run of 1, so 2 over 1. If I look at the other side of our graph, looking here, we have a rise of 2, so it's still a positive 2, but we're going to the left, so it's a negative 1. So the slope on this side is 2 over a negative 1, or a slope of negative 2. Notice how the slopes of each side of your absolute value function graph are opposites. So they should represent the same steepness, but one is a positive slope and one is a negative slope, so they're opposite slopes. And then the important part with graphing absolute value functions is finding that vertex. And finding the vertex is actually really easy to do, and I recommend finding this point first. So to find the vertex, you want to identify this value of x that causes the quantity inside the absolute value to be 0. So in this example here, the part inside the absolute value is just this piece here. We want to figure out when this equals 0, that's where that vertex is going to be on your x-axis. So x minus 3. If x were a negative 3, and I subtracted 3, that's when it's going to equal 0. So in this case, that's where my vertex is going to be. So on a graph, if x is negative 3, it's going to be on my axis at negative 3. This is going to be the vertex of that graph. So find this point first. Find that vertex first. And to find the vertex, you want the value inside the absolute value bars, just what's inside here, to equal 0. Once you figure out where it equals 0, that's where it crosses your x-axis. So one thing that may help you for more complex ones, if you set it up as an equation, x minus 3, I know that has to equal 0. If I were to solve it by adding 3, then x is going to equal a positive 3. And actually, I wrote this wrong. This right here is wrong. This should be a positive 3. So 3 minus 3, and that's going to move this over here. I apologize for that. It should be a positive 3 value of x. And this definitely helps when your equation is like this. It helps when you've got more complex functions. So if, for example, we had like this one back here, since it was x plus 5 divided by 3, if you were to set that equal to 0, you'd be able to more easily find that value for the vertex. So working backwards, dividing by 3 to undo that, I would multiply by 3 on each side so that the division cancels off. And you'd be left with x plus 5 equals 0. And then subtracting 5, the value that would cause that, find that vertex is when x is at negative 5. So it's at negative 5 on your x-axis. So I'll show you one more example with a function to graph the points and finding the vertex. And again, I recommend finding that vertex first. So in this one, x plus 3, I want that to equal 0. So x plus 3 equals 0. If I subtract 3, then my x value for my vertex is at negative 3. So if I plug in negative 3, so negative 3, this is my vertex of this graph. So just finishing to solve it, if I plug in negative 3 plus 3 is 0, the absolute value of 0 is 0, and that negative on the outside doesn't change anything when it's 0. For choosing the next points, remember absolute value functions are always going to be a v, so it's either going to go up on each side, or it's going to go down on each side of this vertex. So to identify, make sure you have both sides graphed, choose coordinates to the right of that vertex and choose coordinates to the left. So if I start with negative 5 and negative 4, that will give me this side of that graph, and then negative 2 and negative 1 will make sure that I've got the other side graphed. So if I plug in negative 5 into this equation, So I'm finding where f is of negative 5. My absolute value function equation is negative on the outside, and then x plus 3. So negative 5 plus 3. That negative is still on the outside. Negative 5 plus 3 is a negative 2. The absolute value of a negative 2 is 2, but that negative is still on the outside. So negative 2 is the y value. If I try it with negative 4, so f of negative 4, plugging in those numbers, negative 4 plus 3 is a negative 1, and that negative is still on the outside. Absolute value of negative 1 is a positive 1. Again, that negative is still on the outside, so negative 1 is here. F of negative 2, hang on. So trying it with f of negative 2, plugging in negative 2 for x. So negative 2 plus 3, we have the absolute value of negative 2 plus 3 is 1. Absolute value of a positive 1 is 1, but it still equals negative 1. And then finally putting in our last number of negative 1. So if we have f of negative 1 equaling negative, and then negative 1 plus 3, we have a positive 2 inside our absolute value. The absolute value of a positive 2 is 2, but that negative is on the outside, so it still equals a negative 2. Notice that some of our coordinates are matching, negative 2, negative 2, negative 1, negative 1. It's giving you both sides of your absolute value graph. And if we finish plotting these points, negative 5, negative 2 is here, negative 4, negative 1, negative 2, negative 1, and then negative 1, negative 2. You can easily see that we've got both sides of our absolute value graph because we've got our vertex and the two diagonal sides. And you'll notice the slope of these ones are below this x-axis. The lines are below because it was a negative on the outside of the absolute value. When the absolute value, there was no negative, then your graph is going to be above. So make sure when you're graphing that you've got both sides graphed and find that vertex first. Again, it's what equals 0 inside the absolute value chunk.